Okay. So far, this has been the most difficult question for me to answer, even though I already had gotten it. I forgot about it, and then I couldn't figure out what to do for the longest time. So, if you guys can read the question, that'll be awesome. Okay, so now we're going to try to estimate the mu of this one. It has multiple steps, so now we're going to just open up Statcrunch. We're going to go to the calculators, customs, and served regions. I'm going to try to work through this as fast as possible. I move it over here, that way I have it available for me to see. I am not the best person to explain this, however, I didn't find it anywhere, so I was hoping that this might help somebody else. Okay, so since we have the mean right over here and we need 4 decimal places, I am going to go to 7. Okay. Awesome. All right. Can we not conduct a goodness of fit test? We can see the problem right over here. Zeros. And then 1, 2, 3 out of 5. Okay, more than 20%. And not all expected counts are greater than 1. We cannot have them be zeros. Now, this portion over here was the most difficult for me to figure out. Of course, we have to go back to our calculators. For the longest time, I called it Poisson. I understand the error of my ways, although I am not the best in mathematics. Okay, for this one, took me the longest time to figure out that we need to go in between. Nope, because we're going to go to 0, 0.5, and we go 4 decimal places, go 0.5, and so on and so forth. 1.5, we compute. Okay, 1.5 and 2.5, compute 0.171, and because we have nines there, 2.5. And we go back to standard because we have to get greater than or equal to 4. So we write 3.5. Fantastic. All right, for this one, what I like to do, and I don't know if you guys want to, we are going to write the the probability. Often forget a lot of different things that I'm working with, so I like to write everything down. And I like to double and triple check because I've gotten answers wrong when I was just a simple decimal point off. I am sure you guys have had that. Okay, for this one, as we can see, is 4 or more. What they did here was clean up a little bit, like I should have. 4 or more, and we got 9. We just added that one right over here. Okay, so what I like to do, because they tell me over here the total number is 571, was just adding these numbers up. I go ahead and compute data, compute our expression. We build it. We're going to use the probability, adding the column, and we multiply it by the number 571. Okay, and I'm going to put the expected number, and we got a brand new data table, which I will go ahead and write over here. 72, we need two decimals. Brings us to 09.61, 98.21, 30.6, okay, 6, and 8.79. Okay, I'm going to go ahead and go back and check again because, like I said, I made those lovely mistakes that unfortunately cost me a letter grade. Yep. All right. Yay. Okay, this one. We need to conduct a goodness of fit test. Level of significance 0.05. Okay. All right, so the hypothesis that we need to do, choose a null and alternative hypotheses below. Okay, well, we already know what the null hypothesis is. They were trying to determine whether or not the probability could be used. So, oh, and that's the only option available. The rocket strikes can be modeled and then not modeled. Okay, and now we go back in to the chart. So we're going to go to our goodness of fit, chi-square, and the observed number of regions with the expected number. And we get our chi-squared right there, 0. We need to go 3 decimal places, 6.5. All right, and our p-value, which is right over here. Oh, sorry. Right over here. So 4 decimal places. So we just write everything down. 5. Okay. Now, since our level, let's state the conclusion, our level of significance is 0.05, and we have a p-value of greater than that, we do not reject the null hypothesis because there is insufficient evidence to claim that it can be used. Excellent. Awesome. Hopefully this has helped you out a little bit because it took me forever, over an hour, to figure it out.